Hello, welcome to Anson Griffin's occasional series of Matlab tutorials on YouTube. First of all, to apologise in advance, I have a bit of a sore throat. I think it's the effect of hay fever, so if I can just excuse me for any coughs that appear. So line 1, just to say the inspiration for this came from that website. And we're looking at max, min and saddle points in Matlab today. Lines 5, 6 and 7, CLC clears the screen, line 6 clears the workspace, and line 7 closes any figures that are open. On lines 8 to 19 are some of the commands used. I didn't use 17, 18 and 19 today because I don't have the Matlab toolbox on this particular machine. Okay, and so we have a number of pauses here. So I'm just going to run this here and we'll just see how we get on. So we have two figures there, and we can suspect here, this is, if we look at this one here, that's figure 1, we suspect that's a minimum, a local min. We suspect that's a local max just there, and there's a saddle point there that you're going from the max to the min, or the min to the max, whichever you want to look at it. And we look at it there, that's just a different view. Okay, so we've seen that, and what we're looking at today is x cubed plus y cubed minus 3x squared minus 3y squared minus 8. So we'll just go to the prompt here, any to continue. So there's figure 3. You can spin this you want, any way you want, by doing that. Whatever way you want to look at it. And just by and large, just as a slight aside here, Matlab does its own heat map. So you see there, the high points are in red and the low points down there are in blue. So this is usually, for a heat map, the highest point would be red, for being hot, and the cold point being blue. Like you're in your guessing game, you're hot, you're cold, you're blue, and when you're getting near, you say you're hot, you're red, etc. Okay, we're still on a pause there. And there we have a contour plot, so let's go back to there. So we did a surf command there, okay, and then we did what we did then was we did a particular view at 140/60, and the one you've just seen there, if I can find it now, that's a contour map. And just look at that. So I'm not going to insult you by explaining what a contour is, but again, this heat map, these are highish points and these are lowish points, and we'll be looking later on at these points here, this contour here and this contour here. How did I do that? I just said contour x, y, z, and I put on some labels there. And as I said, just go back to there, just go back to that. So just note 2, more than likely that's a max or min. Why? Because it's a closed boundary there, and more than likely this is a max or a min there, or perhaps a saddle point. But there's something interesting about 0, 2 and minus 2, 0, which we'll discover later on. So we're going to shift to the main. I should just, those question marks are by, so we're going to shift to the main to -4, -2. Okay, so we're going to -4, -2, so we're shifting it. So we've created XY again, we've done the contour, and here we've done the lin space at 150, so when we look at that again, now when we just get this down here so I can see what's going on. Yep, so we've shifted it to -2 and -4, and that should see again. Now, so we've gone on to the next bit. So we're going to manually label the contours. So we've done our mesh grid at 50 spaces there for the lin space. My z is x cubed plus y cubed minus 3x, plus 3x squared minus 3y squared minus h, and I'm going to label them manually. So using C label here. I have to try and find the right grid. Sorry guys, this is my fault. Yeah. There we are. So I can label there. So there's a contour, -6. I can label that. That's -9, and I could just say label one more there. Now, this you could probably, given that this is pre-arranged, you can see here -60, -30, -9, -6, and this is closed here. So we suspect already around here that this is a local max. If I look at these here, and you can see here I can just about, that's 0 point something, that's -2, that's -6, and that's -9. So we suspect here that this in here is a local min. I hit enter inside the screen. I get the grid on. I just carry on to continue. So I just go back to the prompt there. So I've just done, sorry, my mouse is jumping a little bit today. So I've done on line 77, I've labelled the contours manually, I've got the grid on, I've put on my X label, I've put on my Y label, I've put on a title, etc, etc. I'm on a pause, excuse me now, I'm going to cough. On line 84 and line 85, I'm going to get the max and the min, and you think there's an error here, but let's just go to the command prompt. So, you mightn't have been this before, but when you get the Z, you're getting when you say max Z, you're getting the first max here. You get the max of every column in one row, and then the outer max will give you the max of that row. And not very well explained, giving out to myself, but anyway, it's the maximum value, and then on line 85 we're getting the minimum value. I might look at Z at the very end. At line 86 we're on a pause, and what we're going to do now is on line 87, etc., we're going to get the contours automatically between -14 and -4, just there. I'm not going to show 87. So just go out to the command prompt. Oh, sorry, I've gone too quick. Apologies for that. But anyway, I'd have to run the whole thing again, but just saying we've got all the contours. And now what we want to do is, later on down here, I want to try and, I've gone too quickly because I want to get these just get this down here. So what I've done is I've used a quiver command that I mentioned before, and I've got the directional gradient at each point. So just go back to the thing here. So I've got the contours there. I've said hold on, so line 106 holds the figure that I'm working on, And just to go back to here, if you remember, the function was x cubed plus y cubed plus 3x squared minus 3y squared minus 8. I did the, the differential manually, but the df dx is 3x squared. Df dy, df dx is 3x squared plus 6x, and df dy is 3y squared minus 6y. I could have used the diff and sims command, as I mentioned up at the top there, but as I said before, I don't have the symbolic maths toolbox on this particular machine, so I had to do the differentiation of the original function, i.e. 101, 102, and I had to do that manually. And how I did it manually there it is on line 111 and line 112. Be careful about the dot power. I'm not going to go over this again, but just be careful. This between x squared and x dot squared. X dot squared squares each individual element. Y dot squared squares each individual element of y. The quiver command I've done before. There's a YouTube, but you have to go to my channel Optiplex17, that's OPTIPLEX, the figure 1, the figure 7, and there's a whole load of stuff about the quiver command. So there's the x and y variables, there's gx, gy, so I've got the gradient vectors of gx, gy. Okay, and when I plot, I'll look at the comments now in a second, but when I plot them, there we are now. So I've got this thing. Now remember, a vector has magnitude and direction, and these arrows, I'm going uphill, and this all makes sense because you see here, just you're going minus 12, minus 11, minus 10, minus 9, minus 8, minus 7. So you're going uphill. Okay, we get to minus 5, and you see we're going uphill that way, we're going uphill that way, we're going uphill that way, we're going uphill that way. So we're going up that point there. Minus 2, 0 is a local max. All the gradient vectors are pointing in, they're all coming in at one particular point. They're all going up, so that's a local max. When I look at this point over here, that's 0, 2, all the gradient vectors are flowing away. So you're going uphill that way, 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 that way, that way, that way, minus 11, minus 10, minus 9, minus 8, you're going up the hill. And again, just to emphasize again, blue is low, red is high, so you're in a depression here and you're going up to everything reinforces each other. The gradient vectors are going this way, you're going up the hill in a high heat map. You're going from blue to red. So anyway, that is a max, that is a min. Okay, so hope that helps. Thanks very much for listening. Oh sorry, just one other thing. We do a who's before I go. Remember we had Z there was a 50 by 50, and if I do max, if I just say something like this, max Z equals max Z, I end up, I have a 50 by 50, so there's 50 columns, so that command, I get the max of column 1, I get the max of column 2, I get the max of column 3, column 4, column 5, column 6, column 7, etc. Do a who's. Max Z is a 1 by 50, and then I say max Z equals max of max Z. So that's going to give me the max of that 1 by 50, and I get 28 like I did before. Now I am finished. Thanks very much for listening. Bye.